So I welcome you in the lecture of digital VLSI. So just I want to take the pen. Yeah. So in this particular lecture we will discuss about the basic gate design using MOSFET. So how to design the basic gates like AND gate, OR gate and NOT gate by using MOSFETs. So how to deal with this? In the previous lecture we have discussed about the MOSFET, how MOSFET will work, its characteristics, its types and all in detail. For example, depletion type MOSFET, there are two types, N channel and P channel. Again, there is enhancement MOSFET, there are two types, N channel and P channel. Likewise, we have discussed each and every concept in detail. If you have not watched that video, please go through the playlist and you can watch the entire video. Then if you have not subscribed my channel, please subscribe the channel and press the bell icon so that you will get the latest update of each and every video which I have uploaded on my YouTube channel. So without wasting time, we'll start with the concept, that is nothing but MOSFET as a switch. So there are two types of MOSFET like N channel MOSFET or P channel MOSFET. So as far as MOSFET is concerned, I will say that N MOSFET. Okay, the symbol is like this one, like JFET, but there is a gap in between these two, and this is nothing but P MOSFET. How to remember the P MOSFET? P MOSFET you will find a bubble over here, is one bubble over here, and N MOSFET you will not find any bubble. This is the how to differentiate these two MOSFET. N MOSFET there is a bubble is not there, and P MOSFET the bubble is present over there. So how it works, as our subject name is digital, so everything lies in between 0 and everything lies between 1 only. So what is the effect of this 0 and this 1 to this gate of this transistor? That is nothing but the MOSFET. So suppose if I am giving the 0 at the gate of this MOSFET, N MOSFET, so this will act as an open switch, so that is nothing but the current will not flow from this one. And simultaneously if I am applying 1 to this N channel MOSFET, N MOS I will say that, so this will act as a closed switch, over there. Okay. Likewise for PMOS, if you are applying 1, then it will act as a closed switch, and if my 1 is applied, then it will act as a open switch. So just I want to rub the portion. Sorry. So for NMOS, if you are giving 0, it will act as an open switch, that is nothing but it will not flow the current. If I am giving 1, then it will short circuit and it will connect the current. Like this for PMOS, if 0, that is nothing but the bubble is there. So if I am giving 1, then it will act as a closed switch. If I am applying 1, so if I am applying 0, it will act as a closed switch. If I am applying 1, it will act as an open switch. So how to remember this concept? So think about P MOSFET, bubble is there. Okay, P MOSFET, bubble is there. So bubble, I can say that bubble is similar to 0, bubble is similar to my 0. Okay, so if I am giving 0, then it will act as a closed switch. This will act as a closed switch. And if I am applying 1, it will act as an open switch. So current will not flow in this case. Like this one, like further, like if I am applying 0 to the NMOS, then it will act as a open switch. And if I am applying 1, then it will act as a closed switch. So likewise, you can remember the things of N MOSFET and P MOSFET. So I will rub the portion. Yeah. So we will move forward. So basic gates. What are the basic gates? We know that we are having NOT gate, NOR gate, and AND gate over there. So how these gates will work? That we will see. So basically NOT gate. We know that this is NOT gate. What is the truth table of NOT gate? If at the input I am giving 0, output will be 1. If I am giving 1, output will be 0. So this is nothing but my inverter, I can say that, or NOT gate I will say that. The very basic concept I will tell you. So if you are following the concept, you will get everything of digital VLSI. This is the basic concept, and if you know this concept, then and then you can solve any equation by using your NMOS or PMOS and everything. Okay. So suppose this is my drawing of schematic of inverter. I will tell you how to derive an out, because we suppose if you want to go for this A plus B or C, this is the function, this is the IC. Okay, this is the IC. Output will be like this one. There are 3 inputs and 1 output. So what will happen? How to design by using this CMOS, means IC fabricate. How to fabricate IC for such kind of operation, that we have to see. So in this short, what we are doing, we are designing our not get IC. I can say that not get IC. So how to design that IC and all with the help of digital VLSI, that we have to see. Okay, so first of all, you know the truth table. Yeah, I know the truth table. So what I will do, I will take one PMOS, one NMOS over there. So both I will take, I will connect like this one. The gate of both are connected and short circuited, and I given to the input, because we are having single input. And this drain, drain and source and drain are connected, and I have connected to this terminal, that is nothing but my output terminal. Okay, and the source is connected to the ground, second terminal ground connected. So if I am giving the 1 0, if I am giving 0, then what will happen? Just a minute, I will rub the portion. If I am giving the 0, so 0 here I will also am having 0, and here also I am having 0. So 0, as we know that if 0 is connected to the PMOS, then it will act as a short circuit. So VDD in the digital, I will say that this is 1, and ground it is, I will say that 0. Then it will act as a short circuit, so short circuited with this. So this 1 will carry it out to the output. Secondly, for NMOS I will check 0 is there, so this will act as a open circuited. So 0 will not connected at this output. So finally I will get a 1. Okay, for 0 I will get a 1, 0 I will get a 1. Next time what I will do, I will give 1 as the input. Just a minute, I will rub the portion. 1 as the input. So 1, now what will happen? Again this is 1, again this is 1. So 1, so if 1 is given to the PMOS, it will act as an open switch. So this 1 will not get at the output. But in case of NMOS, if I am giving the 1 as the output, so this will act as a short circuited, and the ground will short circuited, and it will show follow to the output. That is nothing but my 0. If I am giving 1, I will get a 0. This is nothing but my simplest inverter or NOT gate by using MOSFET. That is nothing but the NMOS or PMOS. Again, the very important concept I want to tell you that. So observe this diagram into portion. This upper part which contains my PMOS, and lower part it contains my NMOS. So what exactly this PMOS is doing? This is always give you the output 1. So this is pulling up my output from 0 to 1. From 0 to 1. And the second portion, that is the bottom side, it is always pulling down my output to 0. So whatever the portion in your design, I can say that this is the design of CMOS inverter. So the portion which contains the PMOS, it is always pulling up my input. So this is nothing but my pull up network, and the bottom side which is pull down my output to the 0, this is nothing but my pull down output. Okay, pull down output. So this is nothing but my pull up section, and this is nothing but my pull down section. I think the concept is very clear to you guys. Okay, so I will rub the portion. I will move to next slide. Okay, I think you got the concept. If you got the concept, then please like the session, share with your friends who want to know how this CMOS gates work with basic as a switch and all. This concept is very useful to you guys. Okay, so second is OR gate. Okay, OR gate, or I will say rub the portion, and you have to remember which gate is this one. Okay, which gate is this? Suppose if I am having 2 input, that is nothing but the 4 combination. So 0 0 0 1 1 0 1 1. So in this case what will happen? So what will happen? So 0 0, if I am placing 0 over here, if I am placing 0 over here, okay, 0 over, then what will happen? 0 0 both end. So this PMOS and this is NMOS. If PMOS 0 is there, so what will happen with the output? It will short circuited. So short circuited, my VDD is going to this end. So I will get a 1 over here, and this will not turn on, so this will not give any VDD to this terminal. So I will get what? I will get a 1 over here. Okay, 1 over here. Then 0 1 0 and second is 1. I will rub this portion. I will take pen. Yeah, 0 1. So in this case, what will happen? This again this is 0 and this is 1. So 0, this will turn on, yeah, and this is 1, this will turn on. So both will turn on, and it will give my 1 2 output. So both I will get a 1 output. So I will get a 1 output. Yeah. Third portion. Okay. So I'm having 1 and here I am having 0. So what will happen with this? This will turn on or turn off the device. And what about this? 0, turn off the device. Okay, keep in mind what will happen with this condition. It will turn on or turn off. This is a 0, then what will happen? It will turn off. And what about this? This will again turn off the device. So 1 0, I will get a 0 over here. What about 1 1? Just a minute. Saying 1 1. So 1 1, this will again turn off, but this will turn on my device. This NMOS will turn on my device. So I will get a 1 output. So again I am having 1 output. Okay, 1 output. So if I am connecting inverter over here, then what will happen with the output? This is give my 0, this is give my 0, this will give my 1, and this will give my again 0. So what will happen with this output? It is similar to any gate. Just check whether it is similar to any gate. AND gate, OR gate, OR. AND gate, what is that? If any 0 is there, output my 0. Okay, it is 0, output is 0. It is 0, output is 0. But here there is something mistake over there. What about this thing? Again I am having a 0 over here. Okay, so if OR gate is there, any one output is 1, output is my 1, it should be 1 over there. So 0 0 output is 1, 0 1 output is 1, 1 0 output is 0, and 1 1 output is my 1. So something is missing in this case. So what we will do, you have to find out how to design your OR gate by using CMOS, by connecting this PMOS and NMOS in the correct format, in the correct fashion, so that I will get output as 0 1 1 1. For first case 0 0, I will get a 0, 0 1, I will get a 1, 1 0, I will get a 1, and 1 1, I will get a 1 output. So how to design this thing, that we have to see in this case, how to design these things. Okay, so are you ready to do this? So if you are doing, so comment in the comment box, and you have to post your answers in the next lesson. So thank you very much for attending this lecture. Thank you.